We're continuing with inverse functions, and we're going to need a little refresher on a couple of ideas. This is supposed to be a 3. Okay, suppose I gave you this function. Isn't this a quadratic? It's supposed to be a 3 there. Shift it over 3 spots. So wouldn't it look like this? Do you remember the way we did this was the negative moves it to the right? Okay, now we've also seen something called the vertical line test, where I would imagine a vertical line running anywhere along this picture. Now the vertical line test was great because if I draw a vertical line, I only hit the graph in one spot, it means that at any particular x I'm only getting one y. Does that make sense? And so it would fail the vertical line test if it hit twice. So the definition of a function said that you put something into the machine, you cannot get two y's at the same time. So that vertical line test was super helpful for us. Now, we also had an idea called a one-to-one function. And a one-to-one function had a horizontal line. Now, you see, this quadratic function fails the one-to-one test. So, as I draw a horizontal line, I hit in two different y's. Now, this is what a one-to-one function is. A regular function, you put in any old x, it doesn't matter, and what comes out the other side is a value of y. It has to be a single value. You can't have a machine that suddenly makes two different y's. But if it does, if you put something in and you get a y out the other side, that's a function. But we never said that there couldn't be two different values of x that go into the machine to make that y. We never said that. Now, a one-to-one function, though, is a very special machine, that there is only one thing you can put in the machine to create that one single y. That's one-to-one. Now, inverse functions have to start. So if I want there to be an inverse of a function, it has to start as if it's one-to-one. So this is not one-to-one, and let me show you why it won't work. Remember we said that an inverse function will flip over that line y equals x. So if I flipped this over the line y equals x, I would have this. Well, what's wrong with that? Well, look, the inverse isn't even a function. If I did the vertical line test, it would fail. So this does not have an inverse function because that inverse isn't even a function. Now, there's a trick to fix this. So we can turn something like this into a one-to-one function. And the way we can do that is by restricting its domain. Let me show you what I mean here. So this is the same situation here where I've got a parabola moved over 4 spots. Got this. Okay, so I've moved over 4 spots to the right, and it was supposed to be, and I graphed this. Now, this does not pass the horizontal line test, so this does not have an inverse. But what if we played a little game? What if we chopped it in half? Suppose we used 1/2 or the other, doesn't matter which. We would then create something that's one-to-one. Do you see this would now pass the horizontal line test? And that's precisely what we're going to do. Sometimes we want there to be an inverse, but it naturally doesn't. So what we're going to do is take that original function and chop it in half. Restrict its domain to a domain that is one-to-one so that this works. Now, let me see if I can use theirs. Yeah, let's go ahead and use theirs. So they have then tried to find what would be the inverse. They flipped the x's and y's, the trick we saw in the other video, and they solved for y. But here's the problem. When I took the square root right here of both sides, it creates a plus or minus. Now I sent the 4 over and I've got this. Now here's the problem. The problem is this is not a function, because one value of x would make two y's because of that plus or minus. So what we're going to do is we are going to chop the original function at x is greater than or equal to 4. Or we could have done less than or equal, doesn't matter. Now why did I chop there? Because I knew from the picture that that's where the vertex is. That's a natural place that I can cut it in half, right there. Okay. Now, let me show you what they do next. If we chose to restrict this to be greater than or equal to 4, and this is a reverse machine, it goes the opposite direction, everything gets flipped, then the range of this new, that actually should say inverse. that inverse should be creating y values that are greater than or equal to 4. Does that make sense? Since they're the opposite of each other, the x's and y's have now been flipped. If I restricted that original function for x's to be greater than or equal to 4, well, the inverse must create y's that are greater than or equal to 4, or they're not cut the same way. So now look at the possibilities. We had two possibilities. F of inverse of x, well, let me do it like this. Y is 4 plus or minus the square root of x. That's what we found. Okay, well, we need, if we cut it like this, where x's in the original one were greater than or equal to 4, I need my y's in this new inverse to be greater than or equal to 4. Well, look at this. I've got 4 plus or minus the square root of x. How could I be sure that I'm creating y's that are greater than or equal to 4? I could just use the plus part. If I'm starting with 4 and adding something, then I'm definitely getting to be greater than or equal to 4. This would make it true. So if I'm going to cut that original function at 4 and choose to the right the greater than or equal to 4, I need the y's of this new inverse to be greater than or equal to 4. And this is the way I could do it, by choosing the positive. Now, suppose I had chose to cut it the original function for x is less than or equal to 4. Well, then I would need my inverse machine to be doing less than or equal to 4. All right, when does that happen here? Do you see what happened with the minuses? Isn't this making y's that are less than or equal to 4 because I'm subtracting something away? So I could have chosen the negative. Okay, now if this is unclear, watch me do another one here. Excuse me. So I know that this has been shifted. Oh, actually, I should do all the shifts. I've been shifted 2 over and 3 down, so I'm here. But the point that I need is, where am I going to chop this? I have two possibilities. So I'm going to chop it right here down the center. I could choose x's to be greater than or equal to 2, or x's less than or equal to 2. Either one would work. I need to chop it in half. Okay, well, let's go ahead and do now where we flip the x's and the y's, and I'll show you the rest of the story. Okay, so I need to get the problem part alone. I need this part by itself. So I'm going to add 3 over there. Now I'm going to square root both sides. But when I do, I'm creating plus or minus. Now let's finish by sending the 2 over to the other side. And here's what I've got. I've created something that is not a function. This isn't a function. So what am I going to do? Well, let's suppose we had restricted this originally. We said we're going to choose to cut it in half at 2. Well, then we need our new inverse machine to have values that are creating y's that are greater than or equal to 2. Well, look at this. When would y's be creating something that were greater than or equal to 2? It would be if I choose the positive. This is 2. If I add something to it, it's going to be greater than 2. So if I want to choose this one, I'm going to make an F inverse machine with the positive. If I had chosen this one, then I would have needed the inverses to be less than or equal to 2, which would have meant choosing the negative, because I'd start with 2 and I'd take something away from it. So if I had chosen this one, I would have wanted the negative. Now I know this is confusing, but the basic idea is this. We're just looking at where the vertex is and we're chopping it right there at that point. Now, if I'm chopping it right there, I'm going to find my inverse, and if those were the x's that I needed from the original, I need to make y's like that in the inverse. And so I check that, and then I'm flipping to make sure that they match. So I wanted x's less than or equal to 2. I need y's in the inverse that are less than or equal to 2, and that's how I would build this one, or vice versa. Okay, let's try one here. Now, pause it if you think you got this, you want to try on your own, but I'll show you here. So they have told us, this is the original quadratic function. It's right here at the origin. It hasn't been shifted. And so they told us we're going to slice it right in half here, and we're going to want the x's greater than or equal to 0. So here's what I know. I know that the inverses must create y's that are greater than or equal to 0. I know that. So let's do the old change around where I'm going to send that over. Now I'm going to solve for y. I don't want y squared, so I would square root both sides. So do you agree with that? Okay, now this is not a function because it has the plus or minus here. So, but we're going to choose one where if I wanted the x's to be greater than or equal, I need inverse y's that are greater than or equal to 0. So this is what I hope to turn into my inverse machine. I need these to create positive values of y. Well, when would I do that? Well, not when it's a negative, because that would create negative values. So I'm going to create an inverse machine that has the positive values, because that would make positive y's, which is what I needed. So this now works. This is the inverse machine for this guy if I restrict the domain to be greater than or equal to 0. Okay, now we're going to have something a little different here, and I'll tell you why. What's a little odd about this is that this one, when you create the square root function, has already been restricted, or it's not a function. So when I read this the first time, I got a little confused because this is not broken. This is already a one-to-one function. So if you take the square root of 9, it's technically plus or minus 3. So that doesn't create a function. This would actually technically should look like this. But when they create the square root function, they get rid of this part down at the bottom and make it just the positive values, because if they didn't, it wouldn't pass the vertical line test. So this function is actually already okay. Now, let me show you though what happens when we change the x's and the y's. Now I would square both sides here, like the problem area is isolated. I would square both sides. Now I'm going to send this over to the other side. Oops. I'm going to send this over to the other side. Now, this is actually okay. This creates a quadratic that would be up 4. It creates this. Now, that's actually okay too. This was one-to-one, so we can do this. This is all right, but here's the problem. This doesn't match the original picture. If I drop this over the line, I have created something that has 2 halves, and the original one did not. Now, if you think through the picture, you can already see where we're going to go. I don't want the entire thing. I want half of it. And so the part that would have flipped, if I had restricted my original to be x is greater than or equal to 0, this would be fine. I'd be okay. Do you see what I mean? So let me take you through this again. The square root function is actually one-to-one. It's fine because they intentionally cut off the bottom. Now if I create my inverse, I've created a quadratic. I've created something up here. That's not going to work. So I'm going to limit my domain here to be x is greater than or equal to 0. So I cut the half that matches. Do you see? If I flip this over the line, I need it to match. So if you look at the picture, you can already see what needs to be done. But let's suppose we didn't. Suppose we had done it the way we did before, where I'm going to try to limit this right there at the vertex. Let's say we wanted the x's to be greater than or equal to 4, right here. Okay, well then when I create my inverse machine, I would need y's that are greater than, that are greater than or equal to 4, wouldn't I? That's how we did it last time. Okay, so I need this to create y's that are greater than or equal to 4. Well, when would it do it? Well, it would do it if the values of x started at 0. Do you see what I'm saying? If I put 0 in here, that would create 4. So, how do I make what I need? When this inverse machine is the one restricted for x to be greater than or equal to 0. Now this is confusing. I'm going to take you through it one more time. There's two ways you could have seen this. The original square root function is already 1 to 1. So when I flip it and I do my trick to make the other, though, it creates a parabola. Well, that's not even the original picture. So what I could see there is that I need to chop this in half. I want this side to the right, which is the x is greater than or equal to 0. Now, if that works for you, just go with it. Like, think about the picture and it would be fine. The other way to think of this is, okay, let's restrict it like we did before, like right at the starting point. So where x's are greater than or equal to 4. Okay, let's do that. Well, then we need our inverse machine to make y's that are greater than or equal to 4. So if I made this new machine here, so I get this, how could I get this to make y's that are greater than or equal to 4? I could get this as long as this new inverse machine started at 0, as long as I restricted it at 0, because that would make 4, and if I chose larger x's, it would make 4 or greater. Now I know that's confusing. I hope that made some sense. Let's do one more here and we'll try it. So yeah, this one, yeah, we're going to have to do this the mathematical way because this is not going to be as easy to see what's happening because it's getting moved to the left and it has a horizontal compression. So let's do this the mathematical way that we did on the last one. So I've got my function. Give me just a second here. Okay, I paused this to think this through. Because what I'm seeing here is that on a square root function, since the original is already 1 to 1, because the square root function has been cut already, you're always going to be able to find an inverse here as long as you select a domain where x is greater than or equal to 0. It's always going to work. But I'm going to show you this and mathematically if you want to see it. So I have pulled the 2 out of here in order that I could tell what the shift should be here. And so if I factored out a 2 and I've created 3 halves. So and the plus sign means I've gone to the left. So what I've done here is I've gone, so 3 halves is 1.5 to the left. Now this is a horizontal stretch, but it doesn't really matter what that part of it looks like. So I've just got my square root function moved back 1.5. Now again, the original one, this is 1 to 1. So this is going to be fine. Oh, you know what? Hold on. Maybe I'm incorrect about that. So hold on. So I've pulled this back to negative 1.5 because I moved it to the left. Now let's do our trick. We're going to switch our x's and we're going to switch our y's. Okay, now to get y by himself, we're going to square this. I get x squared equals 2y plus 3. So I've just squared this. Now x squared minus 3 equals 2y. Divide both sides by 2. I get this. That's the square there. Okay, now I'm going to give this 2 to each of them here. And I'm going to make this 1/2 x squared minus 3 halves y, or equals y. Now I'm going to just turn this into decimals so it's a little bit easier to understand. Okay, now our problem with this is a squared function. It's been moved down and it's been compressed, but it's got 2 sides. Now our original one didn't, so we can't have this. We can't have this. So basically our new one is down here somewhere. And although it's been compressed, it has 2 sides. So yeah, let's do this like we did the other ones mathematically. If I had moved this back to negative 1.5, then I want my original x's to be greater than or equal to negative 1.5. And if I want those x's to be greater than or equal to negative 1.5, I would need my inverse y's to be greater than or equal to negative 1.5. Okay, now when would that happen? So if I'm looking down here, when would I get values of y that were greater than or equal to negative 1.5? Well, do you see they would start if x was 0. If I put 0 in for x, then I'm getting negative 1.5. If I'm getting something larger than that, I'm going to be getting values, yeah, that's right. If I'm getting values larger than that, I'd still be getting y's. So if I put in 1, I'm still getting things greater than or equal to negative 1.5. So this would start, I want this new one to be restricted to x is greater than or equal to 0. So I believe I've thought this through clearly. Here's what you're going to do. On these square roots, you can always restrict the new inverse function to be greater than or equal to 0. And the reason that would be true is because the original was already 1 to 1. Okay, now I know this isn't easy, but I hopefully that got you through it. I think the first ones aren't too bad. These square root ones were a little different. It took me a minute to think this through. But you could just restrict the inverse of these square root functions to always just be x greater than or equal to 0.